Welcome to Tesla Info, and today we're going to talk about EV charging and cover the basics. So if you ever wondered why sometimes your car charges at a really slow speed, like trickling in, and sometimes the energy is just piling in, we'll try and explain why. To charge the car, you need a voltage and you need current to flow. And the power that's going into the car is the voltage times the current, and the energy that goes into the car is the amount of power over time. So taking an example, a voltage of 230 volts and a current of 32 amps leads to 7,360 watts, or rounded to 7.4 kilowatts. And for 2 hours, that would be 14.8 kilowatt hours of energy gone into the car. Sometimes you see people talk about miles when it comes to charging. Well, 1 mile roughly equates to a quarter of a kilowatt hour using the EPA test cycle. So 1 kilowatt hour of energy added to the car is the same as adding about 4 miles of rated range. So therefore your 14.8 kilowatt hours in the previous example is about 59 miles of range added. The voltage is pretty much fixed wherever you're charging, so the thing that changes the charge speed is the current. A lower current means a lower charge speed. One common way of trying to illustrate charging is filling up a bucket or a vase in this case. When you're AC charging, you're using an onboard charger in the car, which is the funnel effectively in this case. And it doesn't matter how much water you've got, the rate that the jar or vase can fill up is controlled by the onboard charger. You do get different sizes, so the UMC tends to be slower than a destination charger, but essentially you're still limited. When you DC charge, however, there's no onboard charger involved, and so the flow can be much higher. Although as you see the vase fills up, you have to slow the water down so as not to make a splash or spill anything. And exactly the same principle happens when you're charging a battery. So applying those principles to AC charging in an actual car, you can see that the onboard charger is one of the more dominating factors. But there are actually a couple of other things, one of which is the maximum current the supply can provide, in the water tap in the previous example, and also if the cable's got any limitations in terms of its maximum current capability. When we look at rapid charging, some of those things have been taken away. There's no onboard charger. The cables are linked to the actual rapid chargers themselves, so they're fit for purpose. So those limitations have gone, but we now move on to different limitations, and the key ones are the battery temperature. The cooler the battery, the slower the charge rate. The state of charge, the more the battery is full, the slower it will charge, and the charge itself will have a maximum rate, which may be shared with other chargers in some areas, which actually limits it further. These principles don't only apply to Teslas or Tesla superchargers. Other rapid chargers, this one's a CHAdeMO and a CCS one, both have the same sort of approach and limitations when DC rapid charging. Now let's have a look at the display in the car when you're charging using miles initially in this case. The first figure is the rate that miles have been added, remembering that effectively 4 miles per kilowatt. The second figure is the number of rated miles that have been added during the time you've been charging, so that's the accumulation of the energy that's gone in. The second is the current, which is the 2 figures, the actual current to the max current, and if there's a dot afterwards it means 3 phase, and finally the voltage, which will rarely change when you're charging. If you actually switch to percentage, you'll see the actual kilowatt rate of energy being added, and you'll actually also see the number of kilowatt hours being added, and there's usually about a 4:1 ratio between that and miles. And then you'll also see down the bottom, you'll see there's a maximum current, and on AC charging you can turn that down if you want to override the supply power. Okay, a couple of points to conclude. AC charging is slower than rapid charging, and it may not be the charge point you're plugged into that's limiting your speed. You often hear people talk about plugging into a 22 kilowatt hour charge point and only getting 11 kilowatts. That's because it's your car that's limiting the charge speed. And when you're rapid charging, the best thing you can do is you try and preheat the battery before you start charging. And don't go beyond 80%, because that's when it really starts to slow down.